So here we have a second set of kinetics questions. They're all multiple choice, all past paper questions from old AQA A-level chemistry content. As always, I'm going to suggest that you pause the video on each question, try to answer it, and then when you've had a go through the review, see how you've done, and then work your way through question by question in that way. Let's start with the first question. So quite a lot of information to process here. We need to find which statement is correct for the higher temperature. Now, it's not going to change the area under the curve because that area represents the total number of particles. Now, when I change temperature, I'm not changing the number of particles, so the area has to stay the same. In terms of more particles having the mean energy, it's not true. The mean energy is higher, and that's why the peak has shifted to the right. But actually, you can also see the peak dips. Because we've got more particles with more energy, there are less at the mean. So the opposite is true in that case. Activation energy is not affected. Activation energy is only changed by adding a catalyst. And that takes us to the correct answer, that the area under the curve to the left of the activation energy decreases. That must be true because the area to the right will increase, and we know that's true because more particles have energy equal to or greater than the activation energy. Next question. And again, this is about knowing your way around a Maxwell-Boltzmann curve and knowing what the shape is, but what is important about each part of that shape. So hopefully you have immediately dismissed A and D. B and C are the two most important ones for us on here. One of them is the most probable energy and one of them is the mean energy. And C is the mean energy. The mean energy is always shifted slightly to the right of the most probable. The most probable is the modal, but remember that the mean is going to be skewed by the fact that a small number of particles have very high energies, and that's why it shifts to the right in the way that we see, and we get to the answer C. Next question. So this is a straightforward, do you know or do you not know? This is a fact that you have to take with you. It is the total number of particles that the area under the curve represents. Next question. Okay, so we need to find the true statement. Let's go through them. First one, addition of a catalyst moves the position of activation energy to the right. Now that would actually be increasing the activation energy, and we know that catalysts reduce the activation energy, which allows the reaction to go more quickly. So it can't be that one. The position of the peak of the curve is further away from both axes at a higher temperature. Well, no, at a higher temperature, the peak shifts to the right, which is away from the y-axis, but it also moves down. It's closer to the x-axis, to the energy. Position A does not represent the mean energy, it represents the most probable energy. The mean energy would be slightly to the right of A. And that takes us to the correct answer, C. The area under the curve to the right of the activation energy represents the number of molecules with enough energy to react. If we know the total area is representing total number of particles, then that portion of the area to the right of the activation energy certainly does represent that proportion of molecules and therefore the number of molecules that could react. Final question. And a variation on a very similar theme. It's come up previously even within this video. It's a straightforward factual recall. It's the total number of molecules present that is represented by the area under the curve.